Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati binti Omar, and today I would like to present about our report project for Mathematics 5, COVID-19 cases and vaccination status among Malaysian citizens.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Ruzana binti Abdullah. I will present the introduction, question A, E, and I for this project. In this project, students need to find at least 100 of real data in any chosen field and analyze it by using SPSS software. So our group chose the data from the medical field, which is about the number of accumulative individuals who have fully vaccinated per day from 15 July of 2021 until 21 October of 2021. As everyone knows, vaccination is most common word used nowadays since pandemic of COVID-19 started after the disease outbreak in China on late 2019 and was confirmed by WHO on early 2020. The effect of COVID-19 vaccine varies from person to person, like it does for most vaccines. Every day, the data and information continues to be collected in order to reduce risk of getting this disease and also offer life-saving protection against a disease that has killed millions. This sample data was collected from the Special Committee for Ensuring Access to COVID-19 Vaccine Supply, JKAV, from the website. And it is also co-chaired by the Ministry of Health of Malaysia and Ministry of Science and Technology and Innovation. By using SPSS software, we transfer the data into this software from 15 July to 21 October of 2021, and then to solve question E, which is to find mean, standard deviation, minimum and maximum value for independent and dependent variable. We just click analyze and then at descriptive, click options, and we will find the mean, standard deviation, minimum and maximum value for each variable, and then it will give us the result, which is the minimum for independent variable, which is fully vaccinated, is 3,864,227, and the maximum value for fully vaccinated is 23,565,799, and the mean for fully vaccinated is 14,250,119.87. And for the dependent variable, which is COVID-19 cases, the minimum value is 5,434. The mean is 15,527.65, and the standard deviation is 5,133.8.
This is our scatter diagram and regression line. As you can see, our graph is inversely proportional to the accumulative fully vaccinated per day.
Assalamualaikum, my name is Nurul Shamimi binti Abdul Aziz. Today I would like to explain about the assuming the linear relationship with the least square method to find the simple linear regression model. The equation of the least square line is y hat equal to b0 plus b1 times with x, y hat is the dependent variable, b0 is the y-intercept of the line, b1 is the slope of the line. In this our project, we use two methods for finding the linear regression model. First, by using software SPSS, and second, by using manual calculation. For the SPSS software, the equation of least square line is y hat equal to 21359.816 minus with 0.00409x. And I will show how to get this equation by using SPSS. First, we need to enter all the data for independent x and dependent x. This data that we had from the proposal that we do before. Okay. To generate the equation that we had previously, we need to click the analyze. After that, we need to select the regression and select the linear. And we click statistics to checking, make sure estimate model fit and click continue. After that, we click OK. Okay, this is the data the equation that we had and this in this part. So we can check whether the equation for manual calculation same or not from this SPSS. Okay, for manual calculation, first, before we find the equation y hat, we need to find the sum of x, sum of y, sum of x power of 2, sum of y power of 2, sum of x, y, and n. And this is the step that we use to find the least square line. First, we need to calculate the SXY. The formula that we use is Sxy equal to sum of xy minus with 1 over n time with sum of x time with sum of y. And this is the answer that we get to find the Sxy. For the second step is calculate the Sxx. Sxx equal to sum of x power of 2 minus 1 over n time with a sum of x power of 2, and this is the answer that we get. And for the step 3, we need to find the slope or regression coefficient b1. b1 equal to sxy over sxx. We just put the value that we had before, sxy and sxx into the formula slope, and we get the answer. For step 4, we find the y-intercept b0. b0, the equation is y bar minus with b1 time with x bar. And this is the answer. And after we get all the answer for sxy, sxx, b1, b0, and we can put the answer into the formula of least square line, and this is the answer that we get. If you can see, the answer that we get is the same with the software SPSS. I think that's all for me. Thank you.
Moving on, for question D, check the significance alpha equal to 0.05 of the simple linear regression model in C. Okay, the least square method based on the model in 4.13 or C was a linear relationship square method. So, the sum value of x, y, x, y, xy, x squared, and y squared need to be identified. By applying the concept of y equal to mx plus c to determine the discharge of the slope is either significant or not, we can see from this table, we can see value of the B slope for fully vaccinated is 0.0, while 21359.816 is the constant, which is the intercept of y. So by applying the concept of y equal to mx plus c to determine the discharge of the slope is significant or not, we can see the value of the significance is 0, which is less than alpha 0.05. So we can say that it is significant.
Then for question E, which is interpret the meaning of the intercept and slope in this problem. Please comment any impossible event. In this problem, the meaning of the intercept is described by the intersection point between the regression line and the y-axis. The value is 21359.816.
Next, I will continue to present for the test hypothesis whether the slope is equals to 1 or against unequal to 1 by taking 5% level of significance. So first step is test the claim at 5% of level significance. So here, national is V1 equals to 1 and national equals to V1 against 1. So the second step, we need to determine the t-table. So this is a two-tailed test. So we have S bar here is 15527.65 and n equals to 100. For the sigma, 5133.800. For the uh, interval, 0.5. So here we need to divide by 2, so we get 0.025. So we need to find the T. So here our TC is 1.980. So this is our region. Here is our region for the reject region for the negative, and this is our reject region for the positive. So next, so the decision rule, reject has null if test T falls into the rejection region. So our TC is less than negative 1.980 and TC more than 1.980. So step 3, we need to use t-test. So this is our formula, and then we calculate and we get negative 27727.35. So the decision for the step 4, the decision is to reject the hash null because the test value is negative 2. We get if negative 27727.35, which is lower than the critical value TC because it was in this region. So the conclusion, there is not enough evidence to support the claim that H naught equals to B1 equals to 1.
To explain about the test, the hypothesis whether the intercept is equal to 0 against unequal to 0 by taking 5% level of significance. The hypothesis can be tested by using y equal to b0 plus b1x plus with epsilon, where is b0 is constant, b1 is slope or regression coefficient, y is independent data, x is dependent data, epsilon is error. There are 5 steps that we can test. First, we need to state the hypothesis. Second, write the information. Third is compute MSE and t-test. Fourth is making decision. 5 is conclusion. First, state the hypothesis. The hypothesis is H null B not equal to 0, which one? B 0 unequal to 0 is its claim. For the second step is write the information. In this two-tailed test, by using t-table, the critical value is alpha equal to 5%, and we convert to 0.05, alpha equal to is 0.025, b is 100 minus 2 equal to 98, dc is 1 point plus minus 1.980. This is we get from the table. Decision reject 0 now if t test fail in the rejection region where negative 1.980 is less than TC and more than 1.980. For third step is compute MSE and t-test. First, we need to calculate the SXY, SXX, and SYY. And this is the answer that we get. After that, to compute MSE, we need to find the B1 and B0. It's already get the value also. And we need to find the SSE by using the formula SYY minus B1 uh, time with SXY and equal to 1,995,300,925. And for the MSE, the formula is SSE over n minus 2. SSE that we get previously. So we just put the value on the formula and we get the answer is 20360,210.46. And after that, we do the t-test. This part, we need to do two tests. First, for the t-test one, B1 minus with BC over square root MSE over SXX. And the answer is minus 5.49122921. And for the test 2, the formula is B naught minus with BC over square root MSE time with 1 over n plus x bar power of 2 over SXX. And the answer is 18.51016956. Okay, for the step 4, make the decision. And decision that we make is reject H naught because T test 1 less than TC. And for the last step is conclusion. There is enough evidence to support the claim that constant B naught is the slope and the slope of the regression coefficient B1 is not equal to 0 with alpha equals 0.025. For significance value, it is less than 0.05, which is reject H naught. I think that's all for me. Thank you.
Compute the coefficient of determination and interpret the meaning. Firstly, we click Analyze and click Linear. Here the dependent variable is COVID-19 cases and the independent variable is fully vaccinated people. Then we will get model summary here. So that we know that coefficient of determination of can be interpreted from the regressions model summary, which is table under the R-square column, and 0.235 is the coefficient of. Since R-square is equal to 0.235, which means 23.5%. So the approximately 24% of COVID-19 of the variation in the values of COVID-19 cases is accounted for by an inversely proportional relationship with the number of fully vaccinated people.
Project. In the conclusion, the task given for this project successfully conducted. Based on the presented result, there are some conclusions that we can make from the outcome result, which is first, students were able to analyze the data by using statistical package for the social science SPSS software. Second, there are 100 sets of data were collected to complete this data analysis from the website of Ministry of Health Malaysia. And the third one, from the scatter diagram and regression line, it shows that the COVID-19 daily cases is inversely proportional to the accumulative fully vaccinated per day in Malaysia. The fourth one is the value of mean and the standard deviation for the COVID-19 daily cases is 15527.65 and 51330800027, while the accumulative fully vaccinated per day is 1425019.88 and 6084730.773. So the fifth one is lastly, students who successfully analyzed this data for the COVID-19 daily cases and the accumulative fully vaccinated per day. So that's all from me. Thank you.